Today we're looking at the problem reveal cards in increasing order. So in this problem, we're given an integer array deck. And this deck of cards, every integer is a unique integer. And the integer at the ith card we can refer to as deck I. So we can order the deck in any way we want, and all the cards of this deck will initially be face down. So we're going to do the following steps on this deck until all the cards are revealed. So first we're going to take the top card of the deck, we're going to reveal it, and remove it from the deck. If there are still cards, we're going to take the next top card and put it on the bottom of the deck. Then if there are still unrevealed cards, we just repeat this process. Our goal here is to return an ordering of this deck where we reveal the cards in increasing order. So you can see this example here. The ordering that we would use is 2, 13, 3, 11, 5, 17, 7. And this would allow us to pop in an order that's increasing. So you see we reveal 2, 3, 5, 7, 11, 13, and 17. So let's look at an example a little closer. So let's look at this example here. So we want to take this array that we're given and return an ordering that allows these values to be revealed in increasing order. In this case, that value is 2, 3, 5, 7, 11, 13, 17. So you might think, how do we do this? Do we want to prioritize smaller elements, larger elements, alternate between smaller and larger, or something like this? There's a lot of ways we can go, but what actually is the easiest is to think about, given an array like this, in what order would we process the indexes of the array, right? So say we're looking at arrays or indices 0 to 6, and we put these into an array in order. So what would happen is we'd first reveal 0, and then we remove it from the deck, and then 1 would go to the back of our queue. So then we reveal 2. Get rid of it, move 3 to the back of our queue, then 4, remove it, move 5 to the back of our queue, 6, remove it, move 1 to the back, 3, remove it, move 5 to the back, and then 1, and then finally 5. So you can see we actually found out the order of the indices that would give us a value, right? If we follow this ordering, we can ensure that if we place the elements in increasing order of these indices that we found, then we can actually find an order. So if we take this original array and we sort it, 2, 3, 5, 7, 11, 13, 17. And we kind of go through and we match up this sorted array, and we sort the array because we want the revealed cards to be in sorted order, and match them up to these indices that we found. So you'll see if we put 2 into 0, we'll put 3 into 2, 5 into 4, 7 into 6, and then we'll put 11 into 3, 13 into 1, and 17 into 5. All right. And if you look back at the example, this is the exact same ordering. So what we're actually doing here is not so much thinking about the elements first, but figuring out in what order, if I follow these steps, will the indices be processed. And once we can figure this out, it's very easy to just go through this sorted array and place the elements in there. So what we can do to get this ordering is use a queue. And we will place the elements in the queue, the indices, and then we'll basically process them. So we'll say we're at index 0. And if we have our sorted array up here, we can basically take this first element, put it in 0, and then move on to the next. And kind of just go through the process, finding the indices, moving to this next number, and placing them into that array. So let's hop over to the code and I can show you an example of exactly how this works. So first we're going to sort our deck, and we do this because we know that we want to reveal in increasing order. So to put these in increasing order, we just sort. Then we have our deck index. So this index represents the next element in our sorted array. And we're going to go through this array in sorted order. So this will basically be an index pointing to the next sorted element in our deck. Then we'll start our queue. And what this is going to start with is all the indices that are present in deck. So basically from 0 to length of deck, we're going to add an index. This is going to be our answer array. So this is going to represent the final ordering that's going to let us reveal in ascending order. And these are all set to none initially. So while we still have elements in our queue, we're going to pop off that queue. And this index is going to represent the index in this sorted array that we want to insert the next element in the deck into. So you see we set sorted array at this index equal to the element that the current deck index is pointing to. Then we increment our deck index. If there are still elements in the queue, we basically just take the element that's at the front and put it into the back. Then at the end, we just return our sorted array. So let's submit and make sure this works. Great, and it is accepted. So I hope this is helpful. Thank you for watching.